This video is a set of work solutions to the fifth instalment of my basic skills revision sheet for GCSE Maths higher level. This is specifically aimed at the AQA Link Paired Pilot Methods 2 exam, but all these topics would appear on any GCSE higher level exam. The brackets after the question numbers relate to topic links on my website rawmaths.co.uk, which have individual videos to demonstrate the methods used. There is a link in the comments section of YouTube to the original PDF files, in case you'd like to have a go yourself. Okay, here we go. Question 1. Question 1, rounding numbers to one significant figure. The first significant figure in this number is the 5. Any zeros preceding a non-zero digit is not significant, and therefore we ignore the zeros to start with. After the 5 we would count zeros, but there is no more zeros after the 5, so we round it to the 5. We look at the 6, which tells us to round up to 0.006. List the prime numbers between 10 and 20. Well, you really should know these. Shouldn't have to work them out. Decrease 724 by 2.5%. Well, a quick way of doing this is to figure out if you're decreasing by 2.5%, you're actually working out 97.5%, which is the same as, which implies you're going to multiply by 0.975. So we need to get a calculator out and do 724 times by 0.975, and that gives us 705.9. Because it's kilograms, we don't add any zeros. If it was pounds, we'd add an extra zero to make it to the nearest pence. Question 4. Using a Venn diagram to solve the problem. We have a club of 100 members, 62 males, 35 juniors, and 33 are neither male nor juniors. So how many juniors were girls? So we want to work out how many are in this section here, because they're the juniors that are girls. So if we fill in the rest, so we've got 33 and either male or junior. So we've got 100 minus 33, which is 67, left to fill into this grid here. We're not told how many are both male and juniors, but if we look at the number of males and the number of juniors, we have 62 plus 35. We have 97 in both. So our overlap, the difference between how many we need and how many we've got in, if we add them all together, is 30. So our centre, our overlap must be 30. And that tells us that there must be 32 males because there's 62 males in total. And therefore there are 5 juniors that are not male, which is the answer to the question. Find one way of writing a square of a number less than 50, the sum of two two-digit prime numbers. So the square numbers less than 50, you don't really need anything less than 10 because they clearly can't be written as a sum of two-digit numbers. So let's just write out the ones that might be. Okay, so there's square numbers. Now 16, prime number, well, I could do 13 plus 3, but 3 is not a two-digit number. And I could do 11 plus 5. 5 is not a two-digit number. 25, I could do 11 plus 14, that's not going to work. 25 is an odd number. So we'd have to add 2 to something which is our only prime number, even prime number, which would be 2 to 23. But again, 2 is not bigger than 10, so it's not two-digit. 36 looks our most probable answer. So 36, if I start with 11, that's plus 25, but 25 is not prime. 13 plus 23, that would work. And then I could have 17 plus 19, and that would work. And I believe there's the only 2 possible answers. What is the sum of interior angles on a regular heptagon? Well, a heptagon has 7 sides. And in a polygon with 7 sides, so 1, 2, 3, 4, 5, 6, 7, it's not very well drawn. if we take any corner, we can draw 5 triangles. 1, 2, 3, 4, 5, and each triangle is 180 degrees. So we've got 5 lots of 180, which is 900 degrees. So that's the sum of all the angles on the inside. In general, for any polygon, if you take 2 off the number of sides, so 7 sides is 5 times by 180, that tells you the sum of all the angles inside. It's called the interior angle sum. Okay, question 7. If A is that and B is that, what's the least common multiple of A and B? The least common multiple is the number that both of these two go into. So we're looking for a number that has 2 to the power 2 in it, it has 3 to the power 3 in it, and 5 to the power 3 in it. 3 to the power 2 will go into 3 to the power 3, and 5 to the power 2 will go into 5 to the power 3. So we're looking at 2 to the power 2 times 3 to the power 3 times 5 to the power 3, which is your answer. If we want to write it as a number, it's 13,500. A woman invests £5,000 in a bank account at 3% interest per annum. How many years would it take before she has over £6,000? Well, if we start with 5,000 and we increase by 3% each year, we are multiplying by 1.03. Bring a calculator in, we could do a neat little trick with this. If we put 5,000 and press equals to get our answer, take our answer and multiply by 1.03, that's after 1 year, 2 years, 3 years, 4 years, 5 years, 6 years, and 7 years. So 7 years is equal to £6,149.37. So 7 years is what we're looking for. Using the calculator to find this value, so typing it in with a calculator like this one, it's pretty much type it what you see, and there's no tricks with this one. Just make sure you type it in correctly, and we get 4.07. Usually on an exam this asks you to write down the full calculated display as a decimal, and then you've got to round it to a certain degree of accuracy. 2 significant figures would be the up to the 0 there. That's the first one, that's the second one. Zeros count once you start counting. So we've got 4.1 to 2 significant figures because the 7 rounds it up. Okay, question 10. Calculate the surface area of a cylinder. So we've got a cylinder of height 5 and radius 3. So the surface area, let's just move that calculator over here. The surface area on a cylinder is going to be, if you unwrap it, you're going to get this rectangular piece, which is the size that's wrapped around the circle. So this is the height of the cylinder, which is 5. This is the area of one end, which is pi r squared. And in this case, r is 3, so 3 squared is 9. So that's 9 pi, and that's 9 pi. The only thing we need to think about is this length here, which is going to be the circumference of the circle, because that wraps around the circle. So that's pi times the diameter. The diameter is going to be 6. So we've got 6 times pi, which is 6 pi. So the area of this rectangular section is pi times the diameter times 5, which is going to be 30 pi. We've got 9 pi, and this is 9 pi, so that's 18 pi. So we've got 18 pi plus 30 pi, which is 48 pi. And it asks to leave your answer in terms of pi, so there we go. Question 11. Got a fraction equation. Quite tricky to do these with the x on the bottom. You can make this quite easy to make a mistake on this. But essentially what you need to understand is if we times both sides by x, then that gets rid of the x on the bottom. We have 12 equals 1 2/5 x. And then we just divide by the 1 2/5 to get the answer. So we end up doing 12 divided by 1 2/5, which is 0.4, or we could type the fraction in. And that gives you 60 over 7, which is 8.57. approximately. You may know the technique where you can just switch this with this number here straight away. Those two can be switched, and that would take you straight to this step. Either way, it's the same idea. Factorising this, something a squared minus something b squared looks like the difference of two squares. So if we can rewrite this 4a squared as a number squared, well, 4 is 2 squared and a squared is a squared, so that's 2a squared. 9b squared is the same as 3b all squared, because we do 3 times 3 is 9 and b times b is b squared. And then that can be written as 2a plus 3b and 2a minus 3b. That's the standard method. When we've got two square numbers subtracted, we can write them as a product of the sum of the squares, sorry, the sum of the numbers and the difference of the numbers. Factorising x squared minus 10x minus 24. So when we're looking for this, we're looking for something that multiplies to give us 24, which could be 1 times 24, 2 times 12, 3 times 8, 4 times 6. And because it's minus 24, one of them has to be negative. And when we add them together, we get minus 10. So it's actually the bigger one that has to be negative. So we're trying to see which of those pairs adds up to minus 10. That's this pair, 2 and minus 12. So this is x plus 2 and x minus 12. Obviously you can have that the other way around, so you can have x minus 12, x plus 2. Solving this equation, I think the best way to do this is to multiply through by the 5 and then by the 3 to get rid of the fractions. So if we times 3 by 5, we end up with 3x minus 2 minus 5 lots of x plus 1 all over 3, which equals 5 lots of 1. Then times 3 by the 3, we get 3 lots of 3x minus 2 minus 5 lots of x plus 1, because that 3 cancels with that 3, equals 15, because 3 5 is 15. And now we have a fairly straightforward equation. We just multiply out the brackets to get 9x minus 6. And then we've got to be careful with our negatives. Minus 5 lots of x minus 5x. And minus 5 lots of 1 is minus 5. That's equal to 15. So 9x minus 5x is 4x. Minus 11 is 15. So 4x equals 26. We add the 11, then divide by the 4 to give us x equals 6.5 or 6.5. Write this in the form of a x plus a all squared minus b. So this is the completing the squared form. There's a little clue here that's going to be a takeaway on the end. But the idea here is you start off by halving the 5 to get 2.5. That goes inside the bracket. Because when you multiply this bracket back out again, you're going to get 2.5 lots of x and x lots of 2.5, which is 5 lots of x. And then we're going to end up with a little extra 2.5 all squared, so we need to remove that by taking it away. And then we've got the original takeaway 4. So we just need to tidy that up a bit to get x plus 2.5 all squared, and then we've taken away 2.5 squared, which is 6.25. Take away another 4, it's going to be 10.25. 10 there. And then solving this equation to the nearest one decimal place implies it's going to use the formula where this is the a, this is the b, this is the c. So we're going to use the formula minus b plus or minus the square root b squared minus 4ac all over 2a. So minus b minus 5 minus minus 5 is 5. And then we're going to add and subtract b squared. Minus 5 squared is 25, the square root of 25. And then we've got 4 lots of 2 times minus 4. 4 times 2 is 8, times minus 4 is 32. But I'm doing a minus and times it by a minus, so that's going to be plus 32. And then it's all over 2 lots of a, which is 4. So that's 5 plus or minus the square root of 57 all over 4. So let's bring in the calculator to do that. Let's put it on this side. So we've got 5 plus the square root. Oh, let's actually put the fraction in first. 5 plus the square root of 57 all over 4. And I'll probably write the same thing, but as a decimal, that's equal to 3.1 next to one decimal place. And then the other one, we can just go back in and change that plus to a minus. Get our second solution, and that's going to be minus 0.6 to one decimal place. Okay, the first three terms of the sequence generated with the formula 3n squared minus 2n plus 10. Well, when n is 1, we have 3 lots of 1 squared minus 2 times 1 plus 10. Be careful not to times by the 3 before you square, because 1 squared is 1, times by 3 is 3. Take away 2 plus 10 is going to be 11. So the first term is 11. And then if you put the other put n equals 2, you'll get 18, and then n equals 3, you should get 31. Simplifying this expression, if we try and factorise the top and then factorise the bottom, the top must multiply to give us 12. The x's go there. There's a minus here and a plus here, so one's a positive, one's a negative. They multiply to give us 12, but add to give us 1x, so it's going to be plus 4 and minus 3, because 4 times 3 is 12, so plus 4 times minus 3 is minus 12. Add the 4 and 3 together, we get plus x, or plus 1, and then on the bottom, we need to factorise that out, so we need to take a factor of 2 out, leave us with 2 lots of x plus 3, x minus 3, and then we can cancel out the x minus 3 to get x plus 4 over 2. Now, that might be written as x over 2 plus 2, or a half x plus 2. They're all the same thing, but I would just leave it as this. Question 19. This shape here, I believe, has 9 sides, and they're all the same, denoted by these lines. So that's a nonagon. The exterior angle of which is this one in here, this angle in here, that angle in there is going to be 360 divided by the number of sides, which is 9. Give us 40 degrees. This one's going to be the same, so that's 40 degrees as well. 40 and 40. This angle here is the reflex angle of this angle here. So the interior angle is, let's use a different colour. What's left when we take 40 away from 180? So this interior angle here is going to be 140. So this exterior angle on the outside is going to be 360 minus 140, which is 220. So we've got 40 plus 220 plus a equals 360. So we add those up, we're going to get 300 plus a is 360, so a is going to be equal to 60 degrees. Work out the nth term of the sequence. So what's going up by? This sequence is going up by 4, and it's going up by 6, and then 8, and then 10, and then the second difference is 2. So that tells us it's a quadratic sequence. It's going to be based on 1, 4, 9, 16, 25, the square numbers. Now from there to the sequence we've got, 5, 9, 15, we have to add 4, and then we're adding 5, and then we're adding 6. So we're actually adding the sequence 4, 5, 6, 7, 8, and so on. That sequence goes up by 1, so that's just based on the numbers n, 1, 2, 3, 4, 5, and it's n, that's the n sequence. This sequence that we're adding is n plus 3. So we've got the square numbers, which is n squared, and then we're adding n plus 3, so we've got n squared plus n plus 3. Question 21, a very basic question. You probably know the answer is 37 because they look like they're the same. But on parallel lines with a line cross, these two angles are what's called corresponding angles. And quite often you're asked to explain why your answer, what it is. So corresponding angles are equal. And you've got to know those terms: alternate, corresponding, interior. Find the size of the angle B to three significant figures. It's a right angle triangle, and we're trying to find an angle. So this is to do with trigonometry. Label our sides up for hypotenuse, because it's opposite the right angle. This is the opposite side because it's opposite the angle we're using, and this is the adjacent side. Write out the formulas for the sine opposite of the hypotenuse. So ca to a. We are using the adjacent and the hypo, which is going to be this formula, and we're trying to find the angle of cos. So we're looking at the cos being adjacent over the hypotenuse. The cos of the angle B equals the adjacent side, which is 4, over the hypotenuse, which is 5.2. Bring in our calculator for this, and let's just tidy that up a bit. This implies that B is going to be cos to the minus 1 of 4 over 5.2. When you're finding the angle, you're always using these inverse functions, the shift, sine, cos, tan, to get the sine to the minus 1, cos to the minus 1, tan to the minus 1. So we want 4 over 5.2. Close that up, and we get 39.7 degrees, and we want 3 significant figures, so that's ideal, 39.7 degrees. Find the value of the angle F if O is the centre of a circle. Okay, so whenever I look at angle things like this, I'm thinking about all the different theorems I know about circles. Also, I'm always thinking about labelling where the radiuses are. These are all radii, but they're all the same length because they come out from the centre to the circumference of the circle. So what do I know? Well, if I know that's 20, I know this is 20. Now I could work out this angle and then this angle, and then know that these two are both F. But I can also use the fact that this is a right angle triangle because it's formed in a semicircle. So this angle here is 90 degrees. So F plus 90 plus 20 equals 180. So F equals 70 degrees. Question 24, we have a triangle. It's not a right angle triangle, this is 86 degrees. And we're trying to find the length EG, which is this one here. To do that, we need to use the sine rule because we have two lengths and two angles where the angles and lengths are opposite each other. So the sine rule works along the lines of this, where you have, if you're trying to find the length, it's A over sine A equals B over sine B. Where if I label this A and this little a, because that's what I'm trying to find, and this I'm going to label B and this little b, and then put the numbers in, we get A all over sine of 86 equals B, which is 32 over the sine of 42. So that tells me that A is going to be equal to sine 86 times 32 over sine 42. So bring the calculator in. Sine 86 times by 32 over the sine of 42. And that's equal to 47.7 to 3 significant figures, which is what we want. The last question is a vectors question. OA is the vector A, OB is the vector B, AN and B is in the ratio 2 to 3, and M is the midpoint, so that's 1 and 1 on this side. Okay, find M in terms of A and B. So we're going to go from M to B and then from B to N. So M to B, sorry, let's do M to N is equal to M to B plus B to N. So M to B is just a half of B because the whole way across is B. That's B. So this is midpoint, so that's going to be half B. And then we're going to add B to N. Now that's 3 out of 5, so that's 3/5 of BA. So 3/5 of BA. And BA is equal to minus B plus A. Minus B plus A. So we've got a half of B plus 3/5 of minus b plus a. So that gives us half b minus 3/5 b. We can use a calculator to do the half minus 3/5, or we could change the half to 5/10 and 3/5 to 6/10 and realise that's minus 1/10 b. And then we've got the 3/5 a, so plus 3/5 a. And that's good enough. You could tidy it up a little bit by changing it around to 3/5 a minus 1/10 b. And you could even write it as decimals, so you could have 0.6a minus 0.1b.